Hello everyone, welcome to today's lecture. In today's lecture, we will do some practice questions on the topic differential equations. In the last lecture, we had covered till question number 13. So in this lecture, we will start from question number 14 and we will discuss till question number 20. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Let's start with question number 14, which says we have to find the solution of the equation ln dy by dx is equal to ax plus by is. So again, the hint of this question is we will try to convert each term into y and x, right? Into y and x. We will try to put y terms on one side and x terms on another side, and after that we will integrate both the sides to calculate the solution of this differential equation. Okay. So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. We have basically ln dy by dx is equal to ax plus by, which can be written as dy by dx is basically e to the power ax plus by. Right, now e to the power ax plus by can be written as e to the power ax into e to the power by. Now put y terms on one side and x terms on another side. Therefore, it will be e to the power minus by dy is equal to e to the power ax dx. Now, by integrating both sides, we will get minus 1 by b e to the power minus by is equal to 1 by a e to the power ex plus c. Right, therefore, after solving, we will get b e to the power ax plus a e to the power minus by plus c dash is equal to 0. Therefore, c dash is equal to abc. Clear, c dash is equal to abc. Got it? Therefore, the differential equation, therefore the solution of this differential equation is basically a e to the power minus by plus b e to the power ax plus some constant c. Got it? Therefore, option A is the right choice. Got it? Option A is the right choice. Let's move to the next question, question number 15, which says that the solution of the differential equation dy by dx is equal to e to the power x minus y plus x square e to the power minus y is. Again, the hint of this question is we will try to arrange this differential equation in which y terms will be on one side and x terms will be on another side, right? Clear? So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay. Okay, let's move to the solution part. See, as the given equation is dy by dx is equal to e to the power x minus y plus x square e to the power minus y. When we will take e to the power minus y as common from the right hand side, we are left with e to the power minus y into x square plus e to the power x. Now, on separating the variables, we get e to the power y dy. E to the power y dy is equal to x square plus e to the power x into dx. Now, on integrating both sides, we get e to the power y is equal to x cube upon 3 plus e to the power x plus c. Right, e to the power y is equal to x cube upon 3 plus e to the power x plus c. Got it? Therefore, option A is the right choice, in which we have e to the power y is equal to e to the power x plus x cube by 3 plus c. Right? Therefore, option A is the right choice. Got it? Let's move to the next question, question number 16, which says that if 2 plus sin x dy by dx plus y plus 1 cos x is equal to 0 and y0 is equal to 1, then what will be the value of y pi by 2? Y pi by 2 is equal to what? So again, the hint of this question, we will try to solve this differential equation. You can try to convert this differential equation into the form in which y terms will be on one side and x terms will be on another side, right? After that, you can easily integrate this differential equation to get the solution. Okay, and we have y0 is equal to 1, therefore you will get the value of constant, and after getting the whole solution, you can put x is equal to pi by 2 to get the value of y, right? So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. As the equation is given as 2 plus sin x dy by dx plus y plus 1 cos x, y plus 1 cos x equal to 0. Therefore, by separating the variables in the both sides, that is y terms will be set up with y and x terms will be set up with x, right? Therefore, we will get dy upon y plus 1 is equal to minus cos x upon 2 plus sin x dx. Right. Therefore, after integrating both sides, we will get integration of dy upon y plus 1 is equal to integration of minus cos x upon 2 plus sin x dx. Right. So therefore, we will get ln y plus 1 is equal to minus of ln 2 plus sin x plus ln c. Right. Therefore, we will get y plus 1 into 2 plus sin x is equal to c. Now, putting x equal to 0, we will get y0 is equal to 1. Right. Therefore, by putting the value of x equal to 0, we will get 2 into 2 plus 0 is equal to c. Therefore, c is equal to 4. Thus, by putting the value of c in this equation, we will get y plus 1 into 2 plus sin x is equal to 4. Now, at x equal to pi by 2, we will get y plus 1 into 2 plus sin pi by 2 is equal to 4. Right? Therefore, the required equation will be y plus 1 into 2 plus 1 is equal to 4. Right? Therefore, y is equal to 4 by 3 minus 1, which is equal to 1 by 3. Right? Clear? Therefore, y pi by 2 is equal to 1 by 3 is the right answer. Therefore, option C is the right choice. Got it? Option C is the right choice. Let's move to the next question, question number 17, which says, if a curve passes through the point 2 and 7 by 2 and a slope, that is dy by dx, is 1 minus 1 by x square at any point xy on it, then the ordinate of the point on the curve whose abscissa is minus 2, right? See, abscissa is given minus 2. We have to find ordinate. And the information given in the question is basically the curve passes through 2 and 7 by 2. And the slope, that is dy by dx, is equal to 1 minus 1 by x square, right? Therefore, by using the above given information, we can easily calculate the solution of the curve, that is equation of the curve here. And by putting the value of this abscissa minus 2, we can easily get the ordinate. Clear? Therefore, in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay? Okay, let's move to the solution part C. It is given that dy by dx is equal to 1 minus 1 by x square, right? Therefore, by separating the variables of x and y, x will be separated on left hand side, x will be separated on right hand side, and y will be separated on the left hand side, right? Therefore, dy will be 1 minus 1 by x square into dx. Now, by integrating both sides, we will get y is equal to x plus 1 by x plus c. Now, since the curve is passing through point 2 and 7 by 2, therefore, we will get 7 by 2 is equal to 2 plus 1 by 2 plus c. Therefore, c is equal to 1, right? Therefore, y is equal to x plus 1 by x plus 1, equation 1. Now, at x equal to minus 2, ordinate y is equal to minus 1 by 2 plus 1. That is equal to minus 3 by 2, right? Therefore, ordinate y is equal to minus 3 by 2. Got it? So, option A is the right choice. Minus 3 by 2. Got it? Option A is the right choice. Okay, let's move to the next question. Question number 18, which says, the solution of the differential equation x plus y whole square into dy by dx is equal to 4, in which y0 is equal to 0. y0 is equal to 0 is. Again, see what we will do. The hint of this question is we will try to convert, we will try to separate x and y on each side, or we will try to use inspection method or some substitution to calculate the solution of the above differential equation. Okay. So you have 10 seconds to solve or think about this question. After 10 seconds, we can discuss the solution. Okay. Okay, let's move to the solution part C. We have the equation x plus y whole square dy by dx is equal to 4. Now on putting x plus y is equal to v, x plus y equal to v. Therefore, after differentiating both sides, therefore 1 plus dy by dx will be equal to dv by dx. We get v square into dv by dx minus 1 is equal to 4. Therefore, v square dv by dx is equal to v square plus 4. Right, therefore v square plus 4 minus 4 upon v square plus 4 dv is equal to dx. Right, so v minus 2 tan inverse v by 2 is equal to x plus c. Therefore, x plus y minus 2 tan inverse x plus y by 2 is equal to x plus c. Now, y0 is equal to 0. y0 is equal to 0. Therefore, c is equal to 0. y0 is equal to 0. Therefore, c is equal to 0. Right. So, y is equal to 2 tan inverse x plus y by 2. Right. Y is equal to 2 tan inverse x plus y by 2 will be the solution of required differential equation. Okay. So, option A is the right choice. Y is equal to 2 tan inverse x plus y by 2. Okay. Now, let's move to the next question. Question number 19. Which says the solution of the differential equation dy by dx plus 1 is equal to e to the power x plus y is. We have the given differential equation and we have to basically find the solution of the given differential equation. So what we can do, we can convert each term of x and y and we can separate the variables on both sides, right? Or we can substitute like x plus y is equal to v and differentiate both the sides. And after that, we can take dy, we can convert dy by dx in terms of some dt by dx or dz by dx, like that. So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay. Okay, let's move to the solution part C. We have dy by dx plus 1 is equal to e to the power x plus y. Now let's put x plus y is equal to z. Therefore, 1 plus dy by dx is equal to dz by dx, right? Therefore, we will get dy by dx plus 1 as dz by dx is equal to e to the power z, right? Converting, now separating the variables on each side. Therefore, that is z will be on one side and x will be on another side. We will get e to the power minus z into e to the power minus z dz is equal to dx. On integrating both sides, we will get e to the power minus z upon minus 1 is equal to x plus c. Right, therefore x plus e to the power x plus y plus c is equal to 0, right? X plus e to the power x plus y plus c is equal to 0. Clear, option A is the right choice. Clear, option A is the right choice. Got it? Option A is the right choice. Okay, let's move to the next question, question number 20, which says the solution of the equation x dy is equal to y plus x is equal to y plus x f of y by x upon f dash y by x dx is. Again, see what we will do. The hint of this question is we will try to convert. We can assume y is equal to vx, or we can try some another substitution or another simplification to solve this differential equation. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay. Okay, let's move to the solution part C. As C, when we divide x on both sides, when we divide x on both sides, we will get dy by dx is equal to y by x plus dy by dx is equal to y by x plus f of y by x upon f dash of y by x, right? Therefore, on putting the value of y by x equal to v, as we have discussed, and y by x equal to v, therefore y is equal to vx. Therefore, dy by dx is equal to v plus x dv by dx by differentiating both sides of y is equal to vx. Clear? we get f dash v upon fd dv is equal to dx upon x. Therefore, log mod fv is equal to log mod x plus log c when c greater than 0. Therefore, mod of fy by x is equal to c mod x where c greater than 0. Clear will be the solution of this differential equation, right? Therefore, option C should be the right choice. Why? Mod fy by x is equal to c mod x when x greater than 0. Clear? So in this way, we have discussed a lot of different types of questions based on differential equation. Hope you understood the concepts, how to apply the concepts in the question. Clear? And hope you liked the lecture. Okay. Thank you so much.